The paper of the day is Constant Time Recovery in Azure SQL Database. It's a 2019 paper. Azure SQL Database introduces a novel database recovery mechanism that combines traditional Aries recovery with multi-version concurrency control to achieve database recovery in constant time, regardless of the size of the user transactions. Additionally, the algorithm enables continuous transaction log truncation even in the presence of long-running transactions, thereby allowing large data modifications using only a small, constant amount of log space. These capabilities are particularly important for any cloud database service, given the constantly increasing database sizes, the frequent failures of commodity hardware, the strict availability requirements of modern global applications, and the fact that software upgrades and other maintenance tasks are managed by the cloud platform, introducing unexpected failures for the users. This paper describes the design of the recovery algorithm and demonstrates how it helped them to improve the availability of Azure SQL database by guaranteeing consistent recovery times of under 3 minutes for 99.999, that is 59 of recovery cases in production. Now let's look at the experiments. The paper presents experimental results regarding the performance of the system when CTR is enabled. Following scenarios are evaluated. Performance of recovering and transaction rollback for transactions of different types and sizes. Second, how CTR affects the performance of the system during online transaction processing. Third, background cleanup performance to guarantee that the version store size remains stable and the number of aborted transactions in the system is bounded. Now let's look at the contributions of the paper. Azure SQL Database introduces constant time recovery, CTR in short, a novel database recovery algorithm that depends on Aries but leverages the raw versions generated for MVCC to support three things. First, database recovery in constant time, regardless of the user workload and transaction sizes. Second, transaction rollback in constant time, regardless of the transaction size. Third, continuous transaction log truncation, even in the presence of long-running transactions. Now let's give this paper a PS score. Overall, it's nice and engaging read, so it gets 10 out of 10 on readability. With 12 pages long, it scores 9 out of 10 on length. Reproducibility and repeatability might be challenging, so it gets 7 out of 10. Industry value and learning meter is pretty high, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.